Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and on today's show, we're going to talk about two important things. So, as we all know, Blazor is all the rage these days, and as we all know, testing is important. So, on today's show, we're going to talk about testing and Blazor. And to do that, my guest is Egil Hansen. Hello, how are you?
Doing good. How are you? And thank you for having me.
Thank you for being here. Give us a little brief introduction of who you are for folks that don't know you.
So I am, well, as you said, I'm Egil Hansen. I'm a Dane from Denmark living in Iceland. And I work as a consultant in a company called Delegate. And in my free time, I play around with open source. And one of the things I've created is bUnit, a testing library for Blazor that I guess we will talk about today.
Yes, excellent. So I was going to ask you, the lead-in was going to be, oh, are you familiar with bUnit? How long have you been using it? But you created it.
Yes, it's something I started back in 2019. I do have a strong affinity for writing tests for things I code around, and I was playing around with Blazor at that time, and I saw there was no real good way to actually automate your test of Blazor. So I started doing that, and it ended up being something that actually turned into something useful that many people have been happy with. And now I'm super lucky to have a co-maintainer also maintaining the project with me, Steven Giselle, a guy from Switzerland. So that's been fantastic, and he's been on the team I think 2.5 years now. So
Cool.
sharing the load.
All right. So before we get into it, is it difficult to write a testing framework for something that's young? I mean, 4 years ago, Blazor was still a little young. Is it difficult to write a testing framework for that?
Well, I tend to forget all the pain, so maybe it was, but no. So it's actually an interesting question. I think in this case, the hard part was to be able to figure out how to pull out those inner details of what a Blazor component is and how it is rendered to the screen, but do that in C#. So I didn't want to use Selenium or, well, that was Selenium. I don't think Playwright existed back then, but I didn't want to use something like that to basically have to spin up my component in a browser and then try to test it that way. I wanted to be able to test it like regular unit testing, like we do, where we just new up our class and then we do some things with it, our system under test, and then we change something about it, and then we observe something about it. And for Blazor components, that would typically be the markup that is rendered, or something that a Blazor component, if you interact with it, it might call some service you've injected into it. So things like that. I wanted to be able to test that and test that just in isolation. So the challenging bit was figuring out how to actually not render things to a browser, but render things into something in C# that I could assert against, could work with. And I think around the same time, Steve Sanderson also sort of prototyped he had a prototype for testing in Blazor as well that came out in the fall that year, and I've been working on mine since the spring. And then I could sort of see all the small things I couldn't really figure out. Well, he had done that, so I can sort of steal that. And then he and the Blazor team decided not to pursue their own testing framework, so they just said, well, go use bUnit. It seems to cover most of what is needed. So I ended up inheriting some of the more technical bits from Steven and then being able to build on top of that. So it was challenging, but then Steve and the Blazor team came to the rescue. So
excellent. All right, let's see how it works.
Yes. Okay. So well, we can start just looking at the bUnit.dev website, and let me zoom in so you can actually see the URL. So this is the thing here, and so as I said, it's sort of a library that is aimed at allowing you to test components in isolation. So it allows you to set up a component under test using either C# or Razor syntax. I'll show that a little bit later. And you can verify the outcome either by looking at specific parts of the HTML or And either way, you can use sort of a semantic HTML comparer, so you get more stable tests that way if you are interested in the markup being generated. And then we can obviously inspect the actual component instances and trigger event handlers on those. We can pass in parameters, cascading values, and inject services as well. And then bUnit also comes with a whole bunch of test doubles, mocks, stops, fakes for various first-party services that are built into Blazor. So Blazor has a concept of a IGS runtime, which we use to communicate with JavaScript. We have authentication, we have authorization, we have a navigation manager. So all of those kinds of first-party services that we might inject into our components have support or have fakes or mocks or stops built into bUnit that we can use, so we can easily get going with that. So
cool.
Let me, well, actually, I have a small demo app set up so we can have something to test. I think one thing I want to mention, though, that commonly shows up. So bUnit doesn't care about if you are creating a Blazor server or Blazor WebAssembly or Blazor web app, standalone server-side rendered kind of thing. Are you using streaming rendering, or all the new fancy rendering methods we have in .NET 8? Because bUnit itself is sort of its own render method. So if you have a Blazor component, independent of whether it's built for WebAssembly or Blazor Server or one of the other render models we have now, bUnit doesn't care. So you can test it. You can use bUnit to test it either way. And as hinted to previously, it's not Playwright. Playwright is a way for us to spin up a Blazor application and instrument a browser that will then navigate around the page and click on things for us and fill in forms and so on and so forth, and have sort of a full end-to-end thing. bUnit doesn't do that. bUnit doesn't run in a browser at all. There's nothing like that involved. So when you test a component, you test that in isolation. You can obviously test component trees where you have multiple components sitting underneath that. But there's no JavaScript, there's no CSS that is part of that test. It's only bUnit allows you to focus only on the generated markup and the C# logic. So if you want that full end-to-end experience, and that's definitely valuable, especially if you're building Blazor applications, you can also look at Playwright for sort of a different thing. But bUnit allows you to test components in isolation, which has some benefits as well. So I have this standard Blazor application, and let's just boot it up so we can have a look at see what's going on there. So it's more or less the standard hello world. You do find a new project in Visual Studio and ask for a Blazor application in .NET 8, and this is what you get. I have added an extra component just for us to have something additional to test against. This is just a bootstrap alert component, which can be dismissed. But other than that, we have the weather component, which loads some weather forecasts, and then we have our counter component. Now, we can start by just showing what I call the hello world test for bUnit, and we use the counter component to sort of illustrate how you can test something with bUnit. So if we jump back into Visual Studio, actually let me just close this down so the debugging session stops running. There we go. Now, so there's so one thing. No, actually, sorry. Let me backtrack 1 second. So I want to show you what the testing project for bUnit looks like, and so bUnit is just a testing library that you can include in your XUnit or NUnit or MS Test, or I think there's some other fancy testing frameworks out there. So bUnit isn't a test framework. You still have to create a testing project, and in this case, I've created the XUnit test project. I've made a few adjustments to it. I've enabled the Razor compiler in the test project by including changing the SDK type from Microsoft.NET.SDK to Microsoft.NET.SDK.Razor. But other than that, I've just included bUnit and Verify, which is a snapshot testing library, and its bUnit variant. I've included that as well. But other than that, this is just an XUnit test project, as you can see. Now, if you don't want to do this by hand, we do have on the NuGet repository, we do have a way to basically do this for you. So if you go to nuget.org and install bUnit template here, if you install this template, you will also get it in Visual Studio. And I'm not going to go through it here, but basically you can ask to create a project, and you get to choose which framework you want to target, and which testing framework as well you want to use. So we have support for these 3 out of the box, but you can in theory use anything that basically allows you to new up a C# class. So that's basically what I did here. And so once you have that set up, because we've enabled the Razor compiler to run, we can go ahead and write our tests in Razor files, which has some advantages. So the first one I actually want to show you is this one. This is, as you can see, it's just a Razor file with a code block. And the first thing we get here is we new up something called a test context, which is a bUnit thing. And with that, we get a render method. And into that, we can pass a render fragment. So a render fragment is sort of this concept from Blazor that is basically, it's some markup that we've defined. And in this case, we're just telling it to render out the counter component. And once we have done that, we get something called a component, or I abbreviate that to component under test. So if you're familiar with testing nomenclature, you might be familiar with system under test, but this is component under test. And so if you remember how the counter component works, well, we go and we find the button, and then we click that. So we have a few things going on here. So this first part here, we say, I want to go into the markup that is generated by rendering my counter component, and I want to search for something that matches this CSS selector. So that is the button in this case. So we're just looking for the element of type button. And then we can trigger the onClick event handler that is attached to that element. So, and once we do that, well, the next step is to go in again and look at the document, the rendered markup, and go and find the P tag, the element tag that actually has the role of status, and get the text content out of that. And once we have that, we can assert that our current count now is not 0, but it's 1 in this case. So we can also click and go here to it. So you can see we have, this is the counter component up in our standard Blazor application, and you can see this is the paragraph element. And we're searching for it by the role. I could also just search for the P element, but this is more specific, and we are basically allowing us, when we're doing it like this, we're allowing us to go and maybe refactor our paragraph element slightly. So instead of having this be P tag, we can change it to something else, and the role is, as long as the role stays the same, that is what we are searching for and finding in our test. So this is sort of a whole discussion we can go into about how to create stable tests. And the general idea you want to take the approach where you use the component as the user would. So if you're creating a Blazor application, you want to make sure that you also, when you interact with the component while you're testing them, that you are focusing on some of the externally observable behavior of that component. So in this particular case, our counter component has something called a button. It has a button element somewhere that we want to find and we want to click, and then it has some status element that we can go and find the text content of. So, but one thing that's also nice to do in terms of creating stable unit test is to not have to do something like this, which isn't really test specific. Like here, we are newing up the test context every time that we are running this test. So we still need to new it up every time, but we can sort of, avoid having this code in all of our tests. And it's actually quite easy. So in XUnit, we just inherit from the test context instead. And now the render method is part of our test class, and it'll work the same. So for XUnit, you can do this. For InUnit and MS test, you have to take one additional step because the way that the test frameworks work, where you don't necessarily get a new instance of your class every time for every test. But other than that, it's more or less identical. So you simplify things ever so slightly.
Cool.
Now, just interrupt me if you have any questions along the way. So
I will.
Okay, good. Another thing that you typically do is we have the weather forecast page. So you remember this forecast page is using streaming rendering, by the way, and I've updated slightly from the standard Hello World example. So here we are actually injecting in the weather forecast repository instead of having it directly in the files. So normally it would, out of the box, it would just have some static method that would insert a small delay, and then it would generate some forecast for us. But I want to showcase that the feature of injecting services into the component you're testing. So if we look at this here, so because we are just newing up the component, so bUnit has, on the test context, it has something called services collection. So this looks very much, this works exactly the same as the services collection you have in your program CS, where you go and say builder.services.add scope, and then you add your weather forecast. This is the production code. In bUnit, you do the same thing. You do go and say services and add a singleton, and we want to add a singleton of the weather forecast repository. Typically, when you're writing tests, you don't want to use your maybe your real repository, your real database, especially not if you're sort of in a unit testing kind of scenario. So here I've created a stub of our weather forecast repository, and we can just quickly go and have a look at that. So you can see this is basically the same as the original weather forecast repository, but it's without that inserted delay that is part of the original weather forecast repository. This is the one that is actually being used in production, with this delay where we cheat a bit and we sit and wait and emulate that something is happening. So here we're just returning things, and we can even customize how many we are returning in this stub weather forecast repository. So in this case, I'm just saying, well, just return 2 instead.
So can you use dependency injection there instead of specifying stub weather forecast each time?
You could also have used the real one, but so by default, bUnit doesn't come with any third-party services in its dependency injection container.
Okay.
But there is some first-party services injected already, like the IGS runtime. We have that fake for that, and we have other things like we have a fake for the navigation manager, which is like Blazor's built-in services. But the weather forecast repository, that would be something you as the user or the creator of Blazor application has. That's your own thing, right? So bUnit doesn't know about that. So you would need to go ahead yourself and register those services in bUnit. This is bUnit services container, DI container. And so here we're just saying, well, there's going to be a component with the weather component or weather page component that needs this guy, and we just make a stub or whatever we want available, something that matches that signature that we want to inject into it. Okay. So you could also use MOQ or InSubstitute if you want to use mock, if you want to create a ad hoc mock instead of having something hard coded like I've done here.
Got it.
Okay. Now, other than that, we call and we render our weather component or weather page. I'm not really sure what to call these things. Like it's a page, but it's also a component. So yeah, if you hear me mix these two up, it means the same effectively. So we render the weather forecast page component, and we have that now, and we have to. So and because if you jump into this again, you can see it's uninitialized async method is the thing that calls the repository get forecast method, awaits that and assigns those, and then it'll render out the table. So. Okay. Because our stub is just something that generates them, returns a completed task immediately. So there's no real delay. So it completes right away. So we can immediately go in and say find all. So this is similar to what we had before where we just had find, but in this case we say I'm going to need more than one, well, 0 or more. And here we have again a CSS selector where we say give me all the table rows that is underneath a table body. So that matches what we have in. Here we have a table, we have a table header, then we have a table body and a table row, and we want all the rows. So there's many things you could assert about this, but in this particular case, we're just deciding to say, well, I expect there should be 2 rows now because that is basically what I'm telling my stub to generate. So this is sort of, so this might be a contrived example. So you might not want to assert this, but you might want to assert other things about the markup that is being added into your weather component. But in this particular case, sort of illustrates that you can inject a service in here and change that, and it will work. Now, sometimes you have something that is asynchronously happening in your component that you're testing. And so I've explicitly skipped this, so it doesn't break when we run all the tests. But if we add this back in again and run this test, let me just run all of them. Measure. And by the way, you can see bUnit is really just XUnit tests or in unit.ms tests. So everything works as it works. Like there's nothing special about it. You can run it from .NET from the console with .NET Test or from Visual Studio, as you see here. And we can see here now that yes, this test is indeed failing, and it's failing because it expected to have 2, but we only had 0. So why is that? Well, this time around, I injected in a different stop, something called a delayed stop weather forecast. And in here, I just have a async operation of where I'm just blocking for 50 milliseconds, just to sort of emulate something asynchronous going on. It could also be that you have a component that does some animation, then it waits a bit with a task delay or something else. Now, obviously, this code will just run down here. It will find 0 rows, and then this assertion will fail. So in bUnit, we have a way to deal with that, and that could be because you have an external service, like in this particular case, that has some delay built into it, or maybe you're calling a real database, or maybe you have some animations, or you have some other asynchronous things going on in the render lifecycle of a component. So there's a few methods that we have that helps with that. So in this particular case, we want something that is called wait for elements. And there it works the same way, you just pass in the CSS selector. But as you can see, we also have a few others. We have wait for assertion, we have a wait for single element, we have wait for state. So these are methods that will stop and then listen to the Blazor renderer, the real render that is sitting in the background being driven by bUnit. And every time the renderer does something, every time it does a re-render, it will tell all the wait for methods to, hey, I've re-rendered. Go check if your assertion or whatever you're waiting for now is there, and then you can continue. So we have that deep hook in the bUnit into the underlying structure of the Blazor renderer, so we're able to listen actively for when changes happen and react immediately. So there's
wait for elements basically says wait for all of the elements to finish being rendered. Is that literally what that means?
So essentially what we have here, we have 2 render cycles in this component. We have the loading part where it shows this. The first time it goes through on initialized, then on parameter set, then on after render. And that will show this. And the second time, or rather, as soon as this await here completes, that kicks off another render cycle in the Blazor component, which will then say, well, now these are no longer null, so I will jump into the else branch, and then I will populate my rendered markup with whatever is in here instead. So we're essentially waiting for that second render cycle to come through, which is blocked by the task being slightly delayed by 50 milliseconds. So this gives us that stability of dealing with some asynchronous things going on. And now the test should pass again.
Cool. Very good.
And yes, it did. So that's all good. Let me look at my notes here real quick. Yes. So that was with waiting. So another thing we might look at, and a place where bUnit really shines compared to, for example, something like Playwright, is that the ability to target a reusable component. So sometimes you might create components in your application. So maybe you're even creating component libraries. So I know many of the component library vendors out there are using bUnit for testing their components, because you can, when you're creating component library, if you look at the component library from outside in, what is the externally observable behavior of a component that is in a component library? Well, it's not just the functionality of the application, that there might be a button somewhere that you can click and then something else happens, which is sort of usually the approach you would take if you're testing a Blazor application, because then you sort of have a more user-focused mindset. Users have tasks to do on your applications, and they go from A to B to C usually. So that is what you focus on if you're creating a Blazor application. But if you're creating a component library, you are generating markup and you have functionality that the users of your component library depends on. So there, the observable behavior, the external observable behavior of your components include all of the markup, and maybe also some internal state that your component might be making available to you. So that is something we are able to test with bUnit, which is not super easy to test with something that just looks at components being rendered in the browser. So here we have an example where we have this alert component. And this alert component is the Bootstrap alert component, which is defined up here in Bootstrap website, where it basically shows all the various things you can do with it configuration-wise. So, and we've created a fairly straightforward implementation of it. It has a few public properties. It has child content you can pass into it, of course. You can specify what kind of alert component you want, and the alert kind is one of these, non-primary, secondary, success, danger, warning, info, light, dark. So probably the type you are familiar with if you work with Bootstrap at all. And we have a Boolean here where we can decide whether or not we want to allow our alert to be dismissible. So this is a very rudimentary implementation of an alert component, but something you will see if you find a Blazor Bootstrap library that implements probably something like this. So how can we test something like this? Well, first, we want to render it. And here you can sort of see the advantage of writing this test in Blazor, because you are able to actually interact with the test component you want to test in very much the same way as you would be in just writing regular Razor markup. We also have, if you don't like being in sort of a Razor file, if you want to write your code in just a C# file, you can definitely do that. So we have another method called render components, where you pass in the type of component, and then you have to do something where you basically specify. We have sort of a builder pattern where you specify the parameters. So in this particular case, we want to pass in a few parameters. So we can give this a name, cut2, and then you say parameters.add, and then you can do p over to p.kind, and then you decide we want alert kind of primary, so we match what we have above, and when we can do another add here where we say p over to p dot that was dismissible, I believe. Dismissible, not dismissed, but dismissible, and we set that to true. And then we can do add child content where we pass in hello world. So you can see it's a bit, well, we can reformat this ever so slightly so it's a bit easier to read, but so this is less natural. So that's why if you can live with some of the quirks that is with using the Razor editor, and you don't get all the full features of C# in the Razor editor, this is typically preferred because it quickly becomes a bit burdensome if you have many more parameters or you want to pass in more complex child content. But you can also use the render component method if you want to stay in C# land completely. Now, anyway, cool. I got myself distracted there. So as you remember, so in here, we can write a test that the alert dismiss functionality of the alert component works. So we're basically rendering out alert component, which we set to dismissible. Now, according to the specification over in the Bootstrap documentations, you need to include a button that has the area label of close if you want to have your alert component to be dismissible. So, and then you can click that, and then the alert component should be dismissed. So this is basically what we're doing here. We're going in and finding that. Now, our alert component, as you remember, exposed a public property called dismissed, which you can, if you want to go ahead and the users of the alert component can go and reference the alert component and can see has this been dismissed or not. So you can go and read that property. So it's separate from the parameters, but it's a property. Now, how can we do that? How can we actually access the alert component instance? Well, so in bUnit, we have two trees, I guess. We have the markup of a document object model tree, the HTML being rendered. Then we have the component tree. So we can go into our component on the test, and then we can go and say, we actually want to find the instance of the alert component. And so it will search down the tree. In this particular case, there's only one level to search, which is the root level. So we find the alert component. We have it here. And this exposes an instance property. So it's an iRendered component we get back, and that has the instance property which points to our alert component. And once we have that, we can go and ask, well, was it dismissed? And in this particular case, it was. So that's sort of an example of what you might want to assert. Another thing we might want to assert is, well, to make Bootstrap work correctly, we have to produce the correct markup with the right types of element, with the right types of CSS classes and all of that. And that is something where bUnit allows us to assert against that in sort of a snapshot, inline snapshot testing. So the idea here is we basically provide the markup, that we expect. And so because otherwise, so there's certainly some leeway in terms of how you organize your markup to make the Bootstrap CSS parts happy. But we definitely need fade. We need some of those. It's basically all very well documented, but it's sort of showing us here, well, this is what you're supposed to be doing if you want something that looks like this, right? So
it's almost a kind of UI. It's almost a kind of UI testing, isn't it? Because the markup is UI, and you're here testing that the UI gets written correctly on the fly.
Exactly. Yeah, but obviously, if this was just a string, a C# string, right? You can imagine all sorts of things that could go wrong here that would make this test fail, even though it still is correct, right? So, and that is where we sort of introduced this concept of a semantic comparer in bUnit, and that's the markup matches method. That is sort of the primary thing that exposes that. So what it will do is, well, in short, it understands HTML and understands that two different sets of HTML can be the same, even though they, like, string-wise equality doesn't equate. So we could definitely change something. Well, we could change, maybe we refactor our components so we generate the order of CSS classes slightly differently, or we have some weird white space here, or we could even go ahead and change the order of attributes. So all of this results in HTML that is semantically the same as the thing we had before. And if I run my test and I haven't misremembered how HTML works, the test should still work. And it does. So all the tests still pass here.
Okay.
So that would be this guy here. Yeah, this other test. So this all works. And you can, so there's a whole bunch of edge cases that the semantic compare understands. It understands order of things. It also understands that, well, white space doesn't matter. So this is still good. So it means that I can go into my production code, in my alert component, and change things around. Maybe I want to compact it a bit more. So this shouldn't break my test because functionally it's still the same, right? Or I could change things here. So this is these are some of the steps you can take when you have to do this assertion. When it's important that the markup looks in a particular way, you can still do it in a way that doesn't mean your test is failing left and right all the time, which tend to lead to a whole bunch of, things you don't want to have in your test suite. You don't want your test suite failing when it shouldn't be failing, right? So,
right, exactly.
So, and this is also an example where using something, this is a lot of inline snapshot testing. You have sort of a snapshot of what you want. And we can, in theory, if we go and delete this and run the test again, you will actually see bUnit will tell you pretty precisely what's going on. Let me zoom in here. So it'll give you this warning, say, well, there's some element that was not expected. So this is the actual markup that we got, but this was the expected thing. And because we deleted this p tag in here, well, now it's considered not expected. So we get that error message. So typically what I do when I have to do something like this, I maybe do markup matches and just say, well, I just do this and just pass in the empty string. And then I run my test, and then I get this error message, and then I can say, well, okay, this looks right. So I copy paste this over here, add my dollar sign in front of it. Oh, that's a copy paste. Oh, let me try that again. Just undo. So the idea here is you copy paste it in, and and it will, then the next time you run your test, you have sort of captured that snapshot, and it will work. Now, if you have a whole bunch of variations of this, and you can see I've created a data-driven test here where we try with a whole bunch of different combinations of my alert kind and whether or not it's dismissible or not. Well, you can use verify as well. So we can spend a whole hour talking about verify. It's an excellent snapshot testing library, but here you can just pass, if you include verify.bUnit, you can pass in the component under test, and also tell it what parameters you should that it should consider as well, and it will just create a snapshot. And you can see it's created a whole bunch of snapshot files here that represents all the different permutations of running this test. So that's also a fast way to do that kind of snapshot testing.
Awesome.
And I believe that was sort of my quick hello world of bUnit. So
perfect. That is so
any
cool.
Questions?
No, that's awesome. I think it's, I've been watching testing as it's kind of evolved over time. We've covered testing on Toolbox a
Hmm.
number of times over the years, and it just seems to get more and more doable. I hate to use the word easy in software because nothing's ever as easy as it should be, but very straightforward, very doable. Um,
Yeah.
used to be able to
But
say, well, I don't unit test because it's too hard. Well, you can't say that anymore. You
I don't
can
think so.
say, I don't unit test because I don't. I don't unit test because I don't feel like it, but you can't
Mm.
say it's too hard.
Well, I think a quick comment to that. I think the problem is not that the tooling doesn't make it easy. The problem is that it's actually hard to write good tests that are
Mhm.
easy to maintain and adds real value to your application or product over time. Because just we saw the simple examples I have here, but if you have something in general, not just bUnit testing or Blazor testing, but in general testing, writing tests for complex business logic or complex applications. If you haven't architectured your applications in a way that makes them testable, then you end up with tests that are hard to write.
Yeah.
So it takes so. I think the testing and maybe especially test-driven development is like on a conceptual level, it's easy to understand. Most people can understand red green refactor in a couple of minutes and explain it to somebody else. But actually doing it in practice requires quite a few years of experience to become really good, because you also have to understand design patterns and how do you architect your
Sure.
application and all of that. So it's sort of a multifaceted thing. But yes,
But it's
absolutely.
almost like saying, well, I don't ski because, black diamonds and double black diamonds are too hard, right?
Yes.
It's really, it's pretty
Yeah.
doable to get started and start writing your basic first
Yes.
level of tests so that you get used to it and make it part of
Mm,
your pattern. And then you get better and better and better. So I think
absolutely.
the learning curve is flattened dramatically.
Mm. Yeah, and tooling
I
has
will say.
become much better. Like with Visual Studio and being able to jump around and navigate through your tests and
Yeah.
isolate. I saw there was a Visual Studio toolbox from a couple of weeks ago, I believe, where you were talking about Visual Studio and just testing and just the small thing I had at the bottom of the screen, the testing explorer and all the
Mhm.
different functionality around that. So yeah, on that front, I completely agree with you. It's not the tooling's fault anymore, at least.
Exactly. All right. Well, thanks so much for coming on the show, Egil,
Thank you.
and hope to see you back on the show in the future.
Always, always.
And hope you guys enjoyed that. We will see you next time on Visual Studio Toolbox.